Hey, so welcome back, and this is another daily code problem. So yeah, feel free to let me know in the comments below, like the approach that you took, and also check out in the link in the description. I actually always show like my code and the approach I took and like a written solution. So yeah, feel free to check that out. But let's get to it. So today's problem was called number ways to form a target string given a dictionary. And so we passed this target word that we're trying to create, and we're also given these words here in a kind of particular dictionary that were passed. And so we want to construct this target using these letters in these words. Now there's a bit of a catch here that they explain pretty well, but I'll just kind of go through it quickly here. So I'll just write out these words, and I find just looking at them stacked on top of each other is the best way of thinking of it. And so BBB, and then this last one here. And so these are like different columns that we can consider in these words. And so we have the 0th column, first, second, and then third. And so although we have to build this word like from left to right here, so we have to start by building this letter A, we can consider any of the letter A's in this dictionary, so these 4 here. But the catch is that, say if we want to use this letter here, once you use this letter, you can't use any other letters from this column and the columns that happen before it. So basically, everything here we can no longer use to build this word. And so then when we're making the letter B here, we can either use this letter B or this letter B. So say if we use this one, then we can't consider anything from this point onwards. And then we could either grab this A here or this A here to build the last one, and then you're done, right? And so that is a big constraint here, because we could say, okay, why don't we build this letter A here, the first one. If we grab this one, then there's nothing else for us to pick from, because although we use that letter A here, now when we're trying to create the letter B, we have nothing else that we can consider, okay? And that's kind of just describing that case. Now, because we're also calculating the number of different ways, that could be a really big number, and so we just want to take the modulus of it using this formula here. So we just want to not forget to do that. So we'll want to return the result of like a DP function that we're creating here. We just want to take the mod of it, of this, and I like putting in a constant here. Awesome. And so from here, we want to pass in 2 different parameters. And so we're going to want to consider I and C, and I is going to equal to the like ith letter, or like the ith index of this target string. So the ith index of our target string. And then C will be equal to the column that we're considering, so the Cth column of words. And so because we want to consider one column at a time, say if we're considering like column 0, then that one would be this letter A, or this letter B, or this letter C. Okay? And so to make our lives easier, we're going to create a lookup table. We'll just maybe call it lookup. And it's going to be an array of dictionaries. And it's going to map a string to an integer. And I'll just explain this in a second for every in range, the length of our words at 0. And so we're going to have a lookup table where at every single column, we're going to have a dictionary. So the 0th column will map to like index 0 of this array here. And then it's going to have a dictionary that says, okay, I'll just put it here maybe. So we'll have an array, and at the 0th index, we're going to have a dictionary that'll map, okay, the letter A in the 0th column occurs one time, because there's only one letter A. So we'll do A colon 0 or colon 1. And then we saw that B here also occurs in the 0th index. And so it's going to map to 1. And then also C occurs once. Okay, and so that's the 0th index of this array. But then in the kind of first index, or index number 1, we'll also have like a dictionary that says, okay, we have C that occurs once, B that occurs once, and then A occurs once. So it's like the same process here. Great. And so that just makes our lives easier. So when we're calculating the number of ways that we can build this target string, we can say, okay, we can either use this A, or where's the case where there's 2 of the same letters? Yeah, this column here has 2 C's. So say if we need to build our target with the letter C in this case, we could either use this C to do it or this C. And that's 2 different ways here. And so you want to consider both ways. Okay, so let's just import from collections that default dictionary. And so from here, we want to say, okay, for every word in our words, we're going to want to increment this default dictionary. And so we want to say, okay, let's consider every letter in this word. Spelled that wrong. Then let's say, okay, at this particular word, we want to update our lookup so that at the ith column, because the column maps to this array here, we want to increment the number of occurrences that this letter has appeared in that column. Okay, great. And so that's all the kind of dependencies that we need to make our function here. And so we want to consider 2 different cases for our base case. So base case 1 is that we run out of like target letters. And so that means that we want to return 1 in that case because we were actually able to build this word. So say if we've already created all 3 of these letters and then we index into the kind of 4th index here, because there's no letter there, like we've already built everything else, so we can say, okay, this is a valid path. And so then we just say, okay, if our I, which represents the index of our target string, is equal to the length of our target string, then let's go ahead and return 1. And then the second base case 2 here, is that, okay, we run out of columns. So if we run out of columns, then that just means, okay, we weren't actually able to successfully build this target in this case, or down this path. And so if our column, our cth column, is equal to the length or the number of columns, then we want to return 0 in that case. Okay, because we don't want to consider that particular path, because we're trying to, say if we're looking at, say this was the letter E, we're trying to find an E in here. If we index into the 4th or 5th column here, then naturally that word or that letter isn't there, and so we just want to return 0. Okay, and so that's our 2 different base cases. And so now we just want to create our recursive call here. And so from there, we want to say otherwise, we have 2 other cases that we want to consider going down. And we want to return the total sum of those 2 paths. So like num paths, we'll call it. So the number of paths for this first case, and what this first case is that we could either say, okay, why don't we just skip this column? So don't use any letters in the cth column, move to C+1. And so that will be equal to the recursive call of I to C+1. And so what this means is that we're going to say, okay, although we're looking at, say, index 0 here, we're looking at A in our target, and currently we're looking at column 0. We could actually say, although there is the letter A and we could use it, why don't we just skip this and move on to the next column and don't even consider any paths by using this letter A. And that's represented by here, where we're still going to look at the letter A in our target because I represents the index that we're looking at. But let's just move on to the next column. Okay, and then the second path that we could go down is, there. I don't know what's wrong here. There we go. Is we could say, okay, why don't we use every path of the correct letter in this column. And so why don't we actually consider using the letters that match the kind of target letter that we're looking at in this particular column C. And so then let's add to it, because we want to consider both paths since we're calculating like the total number of ways that we can form it. And so why don't we add to it and say, okay, why don't we increment our I and our C after we've considered every single possible letter that we can use. So because this final column, like 3 here, because 0 index, so this column here where we have 2 letter A's in it, we could use either of these. And so that's 2 different paths. And so we're going to use our lookup table to get the number of paths that we can go down using this particular column at this index. And so what that's going to represent is DP, or no, not DP, the lookup table at this particular column C at our target word's current character that we're looking at. Okay, accepted. And so this won't run successfully. There's just one other thing that we have to consider. And so we're getting a infinite, not an infinite loop, but we'll get a TLE here. And all that we need to fix that is just cache this. And so that's because although we are using this lookup table to make our lives easier, we can actually cache the results of these recursive calls by using this annotation here, and that'll just speed it up just enough so that we can get accepted here and fix that time limit exceeded. Okay, so yeah, I hope that helped. I found this was the main catch here, is if you can kind of think of this lookup table, it can really make your life easier by knowing the number of paths that you can go down. There's then like 2 base cases. We can either say, okay, if we reach the end of our target that we're trying to reach, then let's consider and say, hey, that's a valid path. Otherwise, if we ran out of columns, it's not a valid path. Then there's 2 recursive calls that we can go down. We can either say, okay, hey, let's use this, let's not even use this current column that we're looking at. Let's just move on to consider, say, the following column. And so that's represented by this. Or we also want to consider this column as well, or this path as well, where we actually use any of the letters that match our target. And that's represented by our lookup table. And we want to multiply it by continuing on, because we want to increment and say, okay, we now match that target. And then let's move on to the next column. So yeah, I hope that helped. I think it was a challenging problem. It's definitely a hard one, but I think, simplifying it by thinking of the 2 base cases, and then if you can consider, okay, what are all the possible paths, and we want to add them together, every possible path that we can go down, and just take, remember to take the mod of it, and cache the results. So yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks for watching.